Hello everyone, this is Dr. Lennon, and we're going to go over the second half of the practice exam. So the first one is just kind of reading some information on a graph number 21 here. Domain is the x values where the graph appears, and it continues everywhere from left to right. So that's going to be all real numbers, which we denote by negative infinity to infinity. And the range, notice it bottoms out here at -1, so it goes from -1 at its smallest value and it keeps continuing upward forever and ever. So it's going to be from -1 up until infinity. And we use the square bracket because we're going to include that -1 number. It looks like it touches that level. The x-intercepts, it hits the x-axis in two places, at -4 and at 0. So we're going to do -4, 0. And the y-intercept, it also hits the y-axis at 0, the vertical axis. So that is also there. And to evaluate some function values, f of -2, if we look at -2, the graph hits y value of -1. So -2, -1 is your coordinate. So f of -2 would be -1. And f of 2 is on the right-hand side. If you go to 2 and go upward, it looks like it hits a y value of 3. So the point 2, 3 is on the blue graph. So f of 2 would be 3. All right. Now we're looking for increasing, decreasing, and constant. This function's never constant. It decreases till it hits the bottom of that parabola, which is at x equals 0, and then increases thereafter. So it's increasing from 0 to infinity and decreasing from negative infinity to 0. Okay. So decreasing, as we said, negative infinity to 0. And then it won't be constant anywhere. So over no interval. So it'd be no interval on which the function is constant. Okay, this one here, number 23, basically we just have to pick the correct part of the formula. So we have f of x is this piecewise function with two different formulas. So we use 5x plus 5 whenever x is less than 0, and we use x plus 7 if x is greater than or equal to 0. So for a, f of -4, that's less than 0, so we would use the top formula, 5 times -4 plus 5, which is -15. So we have -15. F of 0, we would use the bottom formula. So f of 0 would just be 0 plus 7, which comes out to 7. And then C, they're going to want us to do f of 1, which again, that's bigger than 0, so we're going to use the bottom formula, which is going to give us 8. Okay, find the slope through 2 points. That's pretty straightforward. We just go ahead and use the slope formula, y2 minus y1 divided by x2 minus x1. So we have 2, 3, and 3, 8. So the slope here is 8 minus 3 divided by 3 minus 2, which comes out to 5. So that's the value of our slope. And a positive slope indicates it's going to be rising from left to right. It's an increasing function. Okay, so for 25, we want to use the point slope formula. So remember, the point slope formula is y minus y1 equals m times x minus x1. So we have m is equal to 5, and it passes through 6, 2. So our point slope form is y minus 2 equals our slope 5 times the quantity x minus 6. So y minus 2 equals 5 times x minus 6. What is the slope-intercept form? That basically means we just take the equation we were looking at and solve for y. So we have y minus 2 equals 5x minus 30, and then we can add 2 on both sides. So y is equal to 5x minus 28. And that's our answer. Okay, number 26 is pretty similar. They give us a parallel line, and the useful part of that is we know parallel lines will have the same slope. So by looking at the second line, we can determine the slope. So we know it passes through -5, -2, and technically it's parallel to y equals minus 4x plus 3. So our slope is -4, so we can use the same formula. Y minus -2 is plus 2, and then we have our slope of -4 times x plus 5, because we're subtracting -5. So that's the point slope form, which is the first part. And then the second part, right in slope-intercept form, again, we're just solving for y. So we have y plus 2 equals minus 4x minus 20. Subtract 2 from both sides, and we'll get y is minus 4x minus 22. Okay, average rate of change is the same as the slope formula. Essentially, we just have to find the y values before we plug them into that slope formula. So for number 27 here, we have f of x equals 3x from x1 equals 0 to x2 equals 5. In fact, we know the graph of y equals 3x is a line, so from that line of reasoning, you know that the rate of change is constant. So really, we actually know the answer is going to come out to be 3, but if we want to use the formula, we'd have to do f of 5, which is 15, 3 times 5, and f of 0, which is going to be 0. And then we would do this the slope formula there with those two ordered pairs. 15 minus 0 over 5 minus 0, and as you see, that comes out to just 3, as we expected. Okay. The next one, is it a polynomial? Well, we don't see any fractional powers of x, we don't see division by x, and all the coefficients are real numbers. So yes, it's a polynomial. The degree is the biggest power of x, which we see is 5. Okay, so for number 28 here, we want to figure out the end behavior. So the end behavior is determined by just looking at the leading term, which is x cubed. So x cubed has a positive coefficient of 1 and an odd exponent of 3. So that indicates it's going to fall to the left and rise to the right. Remember, all polynomial graphs are going to have one of 4 types of end behavior, so you can go back and review that section if you're rusty on that. Find the x-intercepts, state whether the graph crosses. You can actually find the x-intercepts here by factoring this by grouping. So if we look at number 29 here, I'll show you how to do that. So to find the x-intercepts, you set y equal to 0, so we have x cubed minus 4x squared minus x plus 4. So the first two, we can take out x squared, and then we'll get x minus 4. And if we take out a -1 from the second pair, we also get x minus 4. So we see this factors into x squared minus 1 times x minus 4, and that will factor into x minus 1 times x plus 1 times our x minus 4. So we have plus and minus 1 as a x-intercept, and we also have positive 4. So those are our 3 x-intercepts. Where do they cross the x-axis? Well, all of them are just raised to the power of 1, so they have multiplicity 1. If they have an odd multiplicity, they will cross the x-axis. So it crosses the x-axis at each of those 3 x-intercepts. So plus or minus 1 and also 4. and it doesn't touch and turn around at any x-intercepts. There's none with even multiplicity. The y-intercept is pretty easy. That's just the constant term. So the constant term is 4. And does it have any symmetry? Well, it has some even terms and some odd terms, so it does not. If it had only even terms, it would be y-axis symmetry, and only odd terms, odd powers of x, would have the origin symmetry. Okay, so now they want us to graph, so basically we just need to pick the shape, which is this cubic shape here, and then we just want to plug all the intercepts we know. So we know it has a y-intercept of 4, and x-intercepts of 1, -1, and +4. So that gives us the graph. Okay, so now we have some synthetic division. So let's go ahead and do that. Synthetic division is pretty easy. You just have to get the setup correct. We're not missing any terms here, so we don't have to add any zeros. And our number on top, the root of x minus 1 is 1. Then the other coefficients are 1, -4, 5, and -2. So bring down your 1, multiply it by the 1 in the corner, bring it on top of the next, on top of the line in the next column. Add, we get -3, multiply by 1, add again, multiply, add, and we get 0. So this tells us that we have x squared minus 3x plus 2 with a remainder of 0. So we can put our 0 here, that's where the remainder goes, and then we have our x squared minus 3x plus 2. Another synthetic division. This one, again, no missing terms in the thing we're dividing into, the polynomial we're dividing into. But the root is a little more complicated than 1 this time. So we have 6x squared plus 7x minus 29 divided by x plus 3. So our root is -3. And then we have a 6, a 7, and a -29. So again, bring the 6 down to start. 6 times -3 is -18. 7 minus 18 is -11. -11 times -3 is +33. And then when you add, you get 4. So this one is 6x minus 11 with a remainder of 4. Okay, so list all rational roots according to the rational roots theorem for this one. Well, again, it's the possible factors of 12 divided by the factors of the leading coefficient 1. Dividing by 1 doesn't do anything, so it's just going to be all the numbers that divide into 12. So plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, and plus and minus 12 itself. So those are all the possible roots. It says use synthetic division, but again, I'm just going to factor this one by grouping because I know that it factors by grouping. So let's go ahead and do that. So if we have x cubed minus 3x squared minus 4x plus 12 equal to 0, I can take an x squared out of the first two, and I get x minus 3, and if I take a minus 4 out of the second pair, I'll also get x minus 3. So I know this factors into x squared minus 4 times x minus 3, so I get all my factors instantly. So they're going to be plus and minus 2, and also 3. So those are our 3 zeros. So one rational root, they only ask for one of them, let's just enter 2. Then they say, let's find the solution set. We already know that's plus and minus 2 and 3. So a little bit faster than using synthetic division, if you recognize. Again, we're making these the exponents. 5 to the negative second power is 1 over 25. 5 to the negative first power is just a fifth. 5 to the 0 is 1. 5 to the first is 5, and 5 squared is 25. So those are all of our values, and then we see the graph here is B. None of the other shapes really make sense. The coordinates don't match. Okay, so this graph is going to look just like the 3 to the x graph, but the composition plus 2 is going to do what? Well, that's going to send it 2 to the left. Notice if you would plug in -2, you would have a y value of 1. So what's the shape of an exponential? Well, we just saw it in the previous graph. It looks like this. So I think you just click anywhere, and we have the base as 3, which is correct because it's 3 to the x, and we just want to horizontally translate that 2 to the left. And we are all set. It's said also to graph the asymptote, so why don't we do that as well? That should be a line, and it's just this x-axis. We want to make it dotted, though, I believe. So we have a dashed line. So we got both things. And let's go ahead and check that out. Looks good. The equation of the asymptote, well, what's the equation of the x-axis? It's actually just y equals 0. And what is the domain? Well, that's all real numbers. It goes everywhere from left to right. So -infinity up to infinity. The range, well, it doesn't quite get to 0, but it approaches it, and then it goes upward forever and ever and ever, so it goes to infinity. Okay, so we want to write in the equivalent logarithmic form. So for number 35 here, let's go ahead and do that. Remember, the definition of the logarithm says, oh, if we have y equals the log base b of x, that can be translated to the exponential equation b to the y power is equal to x. So we're starting essentially over here, 7 to the x equals 49. And I know it's confusing because we're using x in 2 different ways here. Maybe if it would make it less confusing, I can use a different letter in the definition. Let's not call it x, let's call it something else. Let's call it, I don't know. Let's just say n. So in this case, if we want to translate, we know that our base is 7, so we're going to have the log base 7. N is the thing that's on the right-hand side, which is 49, so the log base 7 of 49, that should be equal to this value x right here. So that's what they want. X equals log base 7 of 49. And you don't need the parentheses. I just like to do it when I write it so that I'm indicating it's the input. Again, to evaluate a regular log like this, the common logarithm, you just ask what power of 10 makes 1 over 10. So what exponent would you raise 10 to get 1 divided by 10? Well, 10 to the negative first power is 1 divided by 10. And for number 37, we're expanding using the laws of logarithms. So there are 3 laws, and one of those says that you can take the factors of an input and separate that using addition. So the log base 14 of 14x, 14 is being multiplied by x, so I can write that as the log base 14 of 14 plus the log base 14 of x. And I know the log base 14 of 14 is 1 because 14 to the first power makes 14. So this can be simplified to 1 plus the log base 14 of x. To evaluate this one on our calculator, I would recommend just using, if your calculator doesn't allow you to change the base, then we're going to just use the change of base property, which says the log base b of x can be written as the log of x, the common log of x over the common log of b. So when I'm doing the log of 0.2 of 25.4, I can write this as the log of 25.4 over the log of 0.2, and I can evaluate that on my calculator. So let me go ahead and grab my calculator and do that. So we get about, how many decimal places do they want? 4 places. So negative 2.0099. Okay, so is this ordered pair a solution of the system? We just need to check and see that both equations work, right? So negative 5 is y, so is 3 times 5, which is x minus 20, equal to negative 5? Yes, so the first equation checks. 5 times 5 is 25, plus 6 times negative 5 is negative 30. 25 minus 30 is negative 5 also, so yes, the solution checks out. Just need to plug in both pairs of numbers and make sure they both work. And then solve by the method of your choice. This one's actually going to be pretty easy because it's not going to take you long to see what's going on here. So this is the last one. 5x equals y minus 6 and 5x minus y equals 7. Well, let me just, keep this one the same. 5x equals y minus 6. And then move the y to the other side, add y, so we would get 5x equals y plus 7. And then you could write them, you could, since they're both 5x, you could say, well, y minus 6 equals y plus 7. And then if you subtract y, you end up with something strange. Negative 6 equals 7, which doesn't make any sense. So we would say the solution set is empty. So that would be choice C. All right, so that is it for the practice exam. Please let me know if you have any questions. Otherwise, this is Dr. Lennon signing off.